you remember our nutrients, right? If you think about your cells, you need a microscope to look at your cells, right? What we see here is the organ made up of tissues. That's very obvious. But we look at the nutrients, they have to get to the cell. So where do you get your nutrients from? Outside? What did you're having pineapple. So what's in there? What did you have for breakfast?
I had a
Pizza? Did you
banana.
have pizza for breakfast?
I wish.
Okay, so in pizza there's carbs, right?
I got pizza.
There's what else did you have? You had coffee.
Banana.
What did you have? Banana. Banana. So
With
there's
potassium.
minerals in there, right? Minerals in the pizza. There's fats in there. Did you have milk? We also have proteins. Maybe you took your vitamins. Maybe some of you are taking some meds. What else? We drank water. Okay. So this one, the carbs, the fats, the proteins, they're too big. You won't see pizza in your blood. You won't see the big chunks of pineapple in your blood. And in your blood, when they get to the blood, remember your capillaries, they're microscopic vessels. They're the ones with the pores to allow your nutrients to be absorbed from your GI tract. It's your blood vessels that will absorb that. And the blood vessels that absorb it are very small. The pores are very small. Your big chunk of pineapple cannot pass through. So this the job of but what's the basic you need to know this. What's the basic building blocks of carbs? It's called yes or monosaccharides. For proteins it is yes, very good, amino acids. And for the fats, yes, free fatty acids. Yes, very good. So in this form, it's able to enter your blood and then able to enter your cells in this form. But in this form, cannot. Okay? That's the job of the digestive system. It has to break down these nutrients from the pizza or the big one to this form. This will enter my cell. The main goal or the eventual uh, purpose is for this to enter the cell. This will be able to enter. This one, the vitamins, the minerals, the water, we're going to revisit them when we're done digesting. This is our first problem. This one, we have to break this down. So the digestive system is nothing but like a disassembly plant. Usually you have an assembly plant, you have the parts, you make an airplane or you make a car. Here, what you do is you break it down, you come up with the smallest unit, and that's the one that can enter your cell. Okay? So, as far as the digestive system is concerned, there are the organs that make up your digestive system. It's called the GI tract. The tube, the one long tube. You see? In the stomach, and then it's just really one long tube, like this. Okay? This is called the alimentary canal or the GI tract. And there are other organs that help them. We call them accessory organs. So the GI tract begins with the mouth. Then you have the pharynx, which is shared with your respiratory system, remember? Then your esophagus, then the stomach, then your small intestines, then the colon, and it ends in your anus, rectum, and then anus. Then to help them do their job, you have accessory organs. You have your salivary glands, you have, of course, the teeth, you have your liver, your gallbladder, and your pancreas. So these are accessory, we call them accessory organs of the digestive system. We can summarize the function of the digestive system this way. It's the one responsible for ingestion. That's how you're able to ingest, put stuff in your mouth. That's part of the digestive system function. It secretes enzymes. That's the key, isn't it? Enzymes are the ones that are able to break down or facilitate the breaking down of chemical bonds from these carbs, the polysaccharides, to come up with this one. The fats, the proteins are called polypeptides, you come up with this one. So you need enzymes. You need to know now the enzyme for carbs is called amylase. This is the only enzyme for carbs. So, okay. So this is your typical polysaccharide, and so this is how your pizza looks like, and it's made up. There's your individual glucose units, okay, but they're bound together. So those chemical bonds have to be broken down if you want to be able to take advantage of the food that you ate. The individual glucose units can, and by the way, you have glucose, you have galactose, you have fructose. Those are the three monosaccharides. But you remember when we were talking about that chapter, by 241, I said, when it gets to your liver, the fructose and the galactose is converted to glucose. So we just say glucose, okay? So to break this bond, you need the enzyme amylase. So what amylase does is break it down to its smallest disaccharide, to disaccharides. You know what disaccharide means, right? It's two glucose units bound together.
Mhm.
And there's the three disaccharides. I'm sure you know your lactose, sucrose,
Maltose.
and
Maltose.
maltose. Very good. So these are three disaccharides. It's made up of two glucose or sugar units. One is glucose plus glucose. One is glucose plus galactose. The other one is glucose plus fructose. But what you need to know is there are three other enzymes. The one that will finally break this down is called lactase. This is a type of amylase. Okay? This one, sucrase. And then this one is maltase. These three enzymes, put a mark on that, this one, okay? These are enzymes produced only by the cells of your small intestines. We'll get back to this one when we get to the part of your small intestines. The other enzymes, the amylase, the big enzyme, the big amylase that can break down this big carbohydrate. It doesn't come from your GI tract, it comes from your accessory organs. Do you follow? So when we ingest our carbohydrate, our potatoes, you have accessory organs that will have first to break it down to smaller disaccharide units. Your small intestine, your own GI tract, can only target the last chemical bond, this last bond. It's only made up of two glucose. This last bond, your GI tract can take care of that. But this big carb, this is how it looks like when we eat it. We depend on our accessory organs to take care of that one. Do you understand? So when you say you're lactose intolerant, you know that your problem is in your GI tract itself, not in your accessory organs. We're going to talk about the accessory organs, but I just want you to know this, okay? Okay. So there's you see there's here in the small intestine, what you're digesting or what you're breaking down is just the last bun. But the big pizza, you need your accessory organs to break all the bonds into smaller ones. Okay? How do fats look like?
Consider. Three. Bar.
See? They look like that, right? So you have to break them down. To digest your fats, the enzyme is called lipase. It's a lipid. The enzyme is called lipase. The one that makes that lipase, or that lipase comes from none other than accessory organs again. You are so dependent on accessory organs. Accessory organs, meaning your uh, what do you call this? Salivary glands, your pancreas, your liver, your gallbladder. You're dependent on them to digest. The the GI tract. Just think of it like. Do you ever go to the? I know you've been to high school where you have your lunch and then you put your food in the. What's that? A belt that keeps moving. So your GI tract is like the belt that keeps moving, but it's dependent on your accessory organs to help you break it down. You see, okay? See, where did the lipase come from? Did it come from your belt, conveyor belt? No, it came from accessory organs. How about your poly? So this one you still have to break it down. How about your polypeptides? How does it look like?
I know it has a nitrogen.
See, look at. This is how they look like. Your steak. This is the individual amino acid. But when you eat your steak, it's just all clumped together. Okay? With this one, you also rely on your accessory organs plus your stomach. We're going to talk about that. The enzyme for, there are several enzymes to digest your proteins. So here it's only amylase. Then I'm sure if you see the word lactase, sucrase, maltase, I hope you don't forget or make the mistake that digest your carbs. Then this one for sure you will know that it's for fat. Then this one, there's many different proteases, meaning protein digesting enzymes. There's lots of them because you have many different types of proteins, like elastase for digesting your elastin. So many proteases, ribonucleases, carboxypeptidase, trypsin, chymotrypsin. So there's a lot of them. Then you will, so you rely on your stomach and your accessory organs. You have to break them down like this, okay, until you get to that terminal one, terminal two carbon, sorry, two amino acid. Then this one can just be acted on by what you call peptidases. Break down the peptide bond, okay? Of these different enzymes, the protein digesting enzymes, the proteases of this one, okay? Don't forget, the proteases, all your proteases are made in zymogen form. So what is a zymogen? This is an inactive form of your protease. This is an inactive protease, the zymogen. Okay. The cells that make up this, the cells that make these proteases are your own cells. Whether it's your stomach cells or your pancreas, they make this enzyme. So pretend that this is your stomach cell, okay? So there's my stomach cell. It makes the enzyme pepsin. We're going to talk about that. Can you imagine what is the most abundant organic compound in every cell? Isn't it
Protein.
protein? Yes, very good. So, if the cell that made the protease, if the cell made it in active form, does it make sense? It will end up digesting its own. This is why it's very important for you to remember the word zymogen. All cells in the body that make protein digesting enzymes, they make it in zymogen form. So it's in zymogen form. They release it onto the surface. It's when they're outside of the body, that then they become activated to the uh, active form, so that they won't digest your own cell. They will digest the food that you ingested. Does it make sense? Okay? So don't forget the word zymogen. You need to also know the term substrate product. This is the substrate. This will be acted on by this enzyme amylase for carbs to produce glucose. You need to remember this. There is the test on GI tract from the test bank is very tricky. I remember there was because you would just see the word amylase, glucose, carbs, and then you just mark it through. I think it says the correct enzyme substrate combination, something like that. You will see the word glucose, but the glucose is referred to as the substrate, and the enzyme is amylase. That's wrong. This is a product. That's the substrate, and that's the enzyme. Please remember that. Okay? So here, substrate acted on by this enzyme, that's the product. Be familiar with those terms, okay? So it secretes. It's also responsible for mixing, making sure, like a match.com, it makes sure that the enzymes meet with the substrate. That's the job of your digestive system. Then you digest. There's two types of digestion. Mechanical digestion, meaning you're chopping down the food to smaller parts, but it is still a big substrate. So you chop down your carbs to smaller carbs. It's just decreasing the size, but it's still carbs. That's what you mean by mechanical. What part of the body um, promotes mechanical digestion? Yes, very good. Like your teeth, right? When you're chewing, is mastication. You should know this term, mastication, meaning chewing. Right? That's an example of mechanical digestion. Then you have churning, which happens in your stomach. So the stomach is powerful. It just breaks it down further to smaller sizes, especially for people like my Baba. In 2 seconds, he's done eating. He's ready to do what he wants to do. Do you have people like that? They're done eating very quickly. They must have chewed on it for 1 minute or 1 second, then the stomach has to do that further chopping called churning. In the small intestine, it's called segmentation. So this is also a form of mechanical digestion. Because the small intestine is very long, so the segmentation means you're keeping it in the segment, allowing match.com again, allowing the enzyme to meet up with the substrate. The other type of digestion is called chemical digestion, which then involves what? Chemical digestion must involve your enzymes. Yes, you have your amylase there, your saliva, enzymes that breaks down the chemical bonds. That's what you mean by chemical digestion. You are now breaking chemical bonds. Then, after you break it down, You come up with your basic products, glucose, amino acids, and fatty acids. What do you do next? You absorb. That's also the job of your digestive system. You have two routes for absorption: your blood for everything else except fat. The fatty acids have to be absorbed through your lymphatics first, remember? Because blood is mainly water and fat does not dissolve properly with water. So first it has to enter your lymphatics. Then there it will be converted to a water soluble form. Then it will join up with your blood. Okay? And then everything you did not, look at this one. Look at this. After you have absorbed, let's see. After you have absorbed everything, look. So I absorb. What is this one right here called feces? So what is feces? It is uh, substances that you never absorbed. It was never a part of you. Is that correct? Right? It was never a part of you. That's why I don't believe in the detox diet. There's such a thing as they say detox. You eat this, it's supposed to take what? It's supposed to detoxify, cleanse your system or whatever. How can the blood, when the blood picks it up, right? Can the blood return it there? No. Where is this blood going to go? To your heart, so your heart can pump it. So how can a detox diet really mean what it says? They say it's supposed to take away whatever toxins in your body, dump it there. It's impossible. Your poop is made up of substances that you never absorb. It's discarded material. Everything that entered your body is now in your circulation. You cannot reverse that. That's not how your GI, your digestive system works. That's why I don't believe in that detox diet. Okay? Okay. So, do you have any questions so far? Let's have a break for 5 minutes, then we're going to move on.